Chapter 6, Types of Switches. An electrical switch is any device that interrupts electron flow in a circuit. Switches are, in nature, binary devices. A switch is either entirely on, closed, or completely off, open. This chapter explores several switch types with illustrations explaining them. Number 1. Toggle switch. The toggle switch is actuated by a lever that angles in one of two or even more positions. The common light switches in your house are examples of toggle switches. Most toggle switches come to rest in any of the lever positions in their array. Think about your light switches. When you switch on, the switch comes to rest at the on position until you turn it off, at which point it rests at the off position. Some toggle switches have an inbuilt spring mechanism that returns the lever to a default normal position. Number 2. Push-button switch. Push-button switches are two-position and activated with a button, which is pressed and released. Most push-button switches have a spring mechanism built in them that returns the button to the UN pressed, out position, at least for momentary operation. There are push-button switches that latch on or off, in alternate fashion, for every push. Others stay in the in position until the button gets pulled back. Number 3. Selector switch. These switches get actuated via a rotary knob or a lever, to select one position out of two or more positions. Like is the case with a toggle switch, the selector switch may rest on any of the positions in the switch's array, or have an inbuilt spring system that allows for momentary operation. Number 4. Joystick switch. The joystick switch has a lever that is free for motion in more than one axis. Think about the analog button in a joystick, where you get to rotate it in multiple directions without restriction. The flexibility is not quite at that level here, but it gives you an idea. One or more than one switch contact mechanism out of several gets actuated, and this is dependent on the direction that the lever is pushed. At times, this is dependent on how far the lever gets pushed. We are not ruling this switch type out entirely, but it is unlikely that the joystick switch would be a fixture in your electric circuit. These switches are mainly used to drive crane or robots. Number 5. Level actuator limit switch. These limit switches resemble rugged toggle or selector switches closely, and they come with a fitted lever that is in turn pushed by a machine part. Frequently, the lever is tipped with a small-sized roller bearing, so that it may not get worn off with prolonged usage. Number 6. Proximity switch. These switches are designed so they sense the approach of a metallic machine part. This sensing is made possible by making it sensitive to a magnetic field or a high-frequency electromagnetic field induced by the machine part. A simple proximity switch uses a magnet that actuates, cause to operate, a sealed switch mechanism every time the machine part gets close. Number 7. Speed switch. This switch type senses the shaft rotary speed, and they do this either by a mechanism that senses centrifugal weight or by non-contact shaft motion detection. This detection could be magnetic or optical. Number 8. Pressure switch. Liquid or gas pressure may be used to activate a switch mechanism. The gas or liquid pressure is usually applied to a diaphragm, piston or bellows, and is then converted from its pressure form to mechanical force. The mechanical force is then used to actuate the switch mechanism. Number 9. Temperature switch. Think of the bimetallic strip, an inexpensive temperature sensing mechanism. It comprises two metals joined in back-to-back fashion to form a thin strip. Each of the two metals has a different thermal expansion rate. When the strip is either heated or cooled, the differing thermal expansion rates causes the metal strip to bend. This bending effect may then be employed to activate a switch mechanism. Some of the more advanced switches, though still relatively simplistic in all honesty, employ a brass bulb filled with gas or liquid, with a small tube linking this bulb to a pressure-sensing switch. When the bulb is heated, the liquid within the bulb expands. The expansion generates a pressure increase, which actuates the mechanism of the switch. Next, let's tackle inverters and charge controllers.